The purpose of this video is to go over how to solve exponential equations. Recall the graph of the exponential function. Let's assume that a equals 1 and b, the base is bigger than 1. So it's an exponential growth with y-intercept at 0,1. A is going to be 1 as an assumption. This function experiences a horizontal asymptote at y equals 0. Its domain is all real numbers. From negative infinity to infinity, its range is all positive number from 0 to infinity. Domain all real, range all positive. When we solve exponential equations, of course, every time we solve an equation, we should verify the answer. However, this one is not as critical as solving other type of equations because the domain is all real numbers. So this one will take anything. So we don't have to worry about, for example, getting the negative answer. But the exponential function could accept negative numbers as well. Let's go ahead and solve these several exponential equations. Let's start with these three. We are going to use the following rule. If b to the n equals b to the m, if the bases are the same, then the exponents must be the same. So in example number one is kind of trivial. 5 to the x equals 5 to the negative 6. Same base, therefore the exponents x must be equals to negative 6. Example number two, very similar. 3 to the x equals 81. Well, we don't have quite the bases are the same. However, we know, by the way, this one could be solved in another way, but attempting to use this rule, we can recognize that 81 can be rewritten as 3 to the 4. 81 is the same thing as 3 to the 4. Now that we have the same basis, what can we conclude? That negative x equals 4, therefore x equals 4, and we're done. Example number 3, we can use the same method. So what do we have? 5 to the x plus 3, 1/5. This is 5 to the 1s, is in the denominator. We can send it to the numerator with negative exponents. It's going to be 5 to the negative 1. Same base, we may conclude that x plus 3 equals negative 1. Therefore, x equals negative 4, and we are done. Two more examples. If we attempt to use the rule that we need to have the same base in order to equal the exponents, well, in this case, we have to find a common base. One way, write 8 in terms of 16, good luck. 16 in terms of 8, good luck as well. However, we can find a common base for both of them, and the common base perhaps would be 2. So we say that 8 can be rewritten as 2 to the 3. 2 raised to the 3, of course, is 8, and 2 to the 4, of course, is 16. And if you recall the rule of exponents, it says that a raised to the m and raised to the n is the same thing as a to the n times, and we may multiply the exponents. So that's exactly what we have here. We multiply 3 times this exponent, so 3 times x minus 3x, 3 times 14, that would be 42, equals 2 to the what? 4 times x, 4x. Same base, we may conclude that the exponents must be the same. So 4x equals negative 3x plus 42. We may add 3x, so 4 plus 3, that would be 7x equals 42 divided by 7, x equals 6. We should review what I'm confident is correct. Same strategy for the next problem. Notice that we need to find a common base. In 9 and 27, the common base will be 3. 3 to the 2 is 9, 3 to the 3 is 27. So let's piggyback on that. So that 9 is the same thing as 3 squared, and 27 is 3 cubed. So now, same rule, power rule. 3 equals 2 times negative x minus 2x. 3 times 15, 45 equals 3 to the 3x. Therefore, 3x equals negative 2x plus 45. We may add 2x. 5x equals 45. We divide by 5. So x equals 45 over 5, which is 9, and we're done. For the next two examples, we are going to recall, of course, the power rule, and also when I multiply two things of the same base, we may add the exponents. So a to the m times a to the m, same base, we may add the exponents m plus n. This example, we have base 3, base 7. If we recall, we may rewrite 27 as 3 to the 3. So that's exactly what we're going to do now. It will be 3 to the x squared minus 7 equals 27 to the 2x, but 27 is the same thing as 3 cubed. So now I have 3 to the x squared minus 7 equals 3 to the 6x. Same base. We must have the same exponents, so x squared minus 7 equals 6x. We are dealing with a quadratic equation, so we equal it to 0. X squared minus 6x minus 7 equals 0. Factors of negative 7, that gives me negative 6. That will be x minus 7, x plus 1. Product rule, zero product property. X minus 7 equals 0, x equals 7. X plus 1 equals 0, x equals negative 1. So we get two solutions, negative 1 and 7. We should verify it. Here, okay, so what do we have? Well, we need to find a common base. Perhaps a common base would be 2. So 4 is the same thing as 2 squared. And that is into it. So therefore we have 2 to the 2x here times 2 to the x squared equals 16. Can be written as 2 to the 4. And that thing is to the 2. So this is the same thing as 2 to the 8. Okay, so now that we have it like that, using this product rule, so now we can add the exponents. So what do I have? 2 to the 2x plus x squared equals 2 to the 8. Therefore, same base, the exponents must be the same. So x squared plus 2x equals 8, quadratic equal to 0. X squared plus 2x minus 8 equals 0. Factors of negative 8, that gives me 4. Plus 2, perhaps x plus 4. Also very thinking of the 4 times x minus 2 equals 0. Yeah, if 4 times negative 2, negative 8, 4 minus 2, positive 2. When x plus 4 equals 0, x equals negative 4. When x minus 2 equals 0, x equals 2. So when x plus 4 equals 0, x equals negative 4. When x minus 2 equals 0, x equals 2. So we get two solutions for this one. What about these two other examples? Notice that it's going to be very difficult, if not impossible, to write 77 as base 10 or 10 base 77. Therefore, we use other type of strategy, which is using, of course, the inverse function of the exponential, which is the logarithmic function. Okay? So we need to use the log. And what is the relationship between log and exponential? Of course, since log and exponential are inverse, so this is the relation. Log base b to the y, log base b of x equals y only if b to the y equals x. Of course, the log is the exponents. The log is just exponents. In this case, we need to change to log base 10, which we don't write, of what? 77 equals the exponent, which is 7x plus 1. 10 to the 7 plus 1 equals 77. Since we are isolating the x, we must subtract 1 and divide by 7. So log of 77 minus 1 equals 7x. Therefore, x equals log of 77 minus 1 over 7. And we are done. The next example, we have this e. So that means the inverse function of e will be ln, natural logarithm. Before we do that, we need to divide by 3. We divide by 3 on the left, we divide by 3 to the right. 3 over 3 is 1. So now I have that e to the 4x minus 5 equals 67 thirds. And now we can change to the equivalent logarithmic equation, which is log base e, or ln of what? Ln of 67 over 3 equal the exponent for x minus 5. So for x, we must add 5 divided by 4. So we have the ln of 67 over 3 plus 5 over 4 equals x. We are done. Okay, let's try the next two examples. Not only we are going to change to logarithms, we also might need the base of our change of base formula that helps me go from one base to the other when we're working with logarithms. So 2 to the x equals 10. We have no choice but to rewrite in terms of log. So what do I have? Log base 2 of 10 equals x. Therefore, x equals, my calculator cannot do log base 2. So I have to change the base. So what do? We just simply do log of 10 divided by log of the old base, which is 2. Notice, folks, that we went here from base 2 to base 10. Or we could have used ln from base 2 to natural log. So this would be, or it could be ln of 10, and we divide by the ln of the old base, ln of 2. Okay, so here we change from base 2 to base e. But let's say in my calculator, I can find the common log, or I can find the natural log. My calculator does not allow me to find log base 2. Example number 11, we need to get rid of this 5, so we divide by 5. So now I have 3 raised to the 4x minus 7 equals 88 over 5. Base 3, we need to change to log, so it will be log base 3 of 88 over 5 equals 4x minus 7. So for x, we must add 7 divided by 4. So that's log base 3 of 88 over 5 plus 7 equals 4x. Therefore, x equals log base 3 of 88 fifth plus 7 over 4. My calculator cannot find log base 3, so I must change base. So this is the same thing as what? I need to change base, so what do I need to do? I need to divide. If I'm going from base 3 to base 10, I use log. If I'm going from base 3 to base e, I use ln. So let me use ln since I use log base 10 here. So we just simply with ln, we divide by the old base, which was 3. We find the ln of 88 over 5. And I will do it. This the calculator will find. What about if they ask us how long it takes for a $100 investment to grow to, I don't know, 250, from 100 to 250, when it's continuously compounded at 9%. or let's say, yeah, 9%. So let's see, we want to take our $100 and grow it to 250 from 2 present value, future value, e to what rate? 0.09 t. How much is t? So we are solving for t for time. Okay, so this is just like example number 11. It's just written the other way around. So let's divide first by 100. So now what do I have? I'm going to write it the other way around. So I have E 0.09 t equals 250 divided by 100. That will be, of course, 2.5. So back to basic, folks. So ln, I mean, since I have E, we need to convert to its inverse functions. That will be ln of what? Of 2.5 equals 0.09 t. E to the that equals 2.5. Since I'm solving for t, we just simply have to divide by 0.009. So therefore, t is going to be ln 2.5 over 0.09, and we are done. Example number 13 will be very complicated. Well, not that complicated. 1 minus 2x equals 4 to the x. In this example, we have to use the following property. Property states that if we have, if m equals to n, then log base b of m equal log base b of n. You have an equality, that means that I apply log both sides of the equation, or ln both sides of the equation. So log base b, any base, so we can use base 10 or base e. So let me use base n, base e, I'm sorry. So this is what we have. 3 to the 1 minus 2x equals 4 to the x. We apply ln on the left, ln to the right. And let's see what happens. If you recall, we have the product rule that states that log base b of m to the r equals r times, this r can be brought to the front, log base b of m. Likewise, so this is 1 minus 2x can be brought to the front as multiplication. So parentheses 1 minus 2x times ln of 3 equals, we bring the x to the 4 times ln of 4. I must break this parenthesis, so what do I have? Ln of 3 minus 2 ln of 3 times x. Okay, so 2x equals ln of 4 times x. Remember, ln of 3 is just a number, ln of 4 is just a number. Since I'm solving for x, I want all the terms that contains x one side of the equation. So I'm going to add this one to the right-hand side. So I have ln of 4 times x plus 2 ln of 3 times x equals ln of 3. Of course, I have ln of 4 times x, 2 ln of 3 times x. Notice that we can factor the x. It will be ln of 4 plus 2 ln of 3. Times x equals ln of 3. So now solving for x, of course, we can divide by this number. So therefore, x equals ln of 4 plus 2 ln of 3 over ln of 3, and we are done. We can punch in this in the calculator to find the actual value.